What if I told you an 18-year-old kid from Texas built a 500-horsepower engine for $75 that embarrassed million-dollar racing programs? Not with exotic parts or factory backing, but with a wrecked Buick engine everyone else thought was junk. This is the story of how David Pearson outsmarted the entire muscle car establishment with nothing but mechanical genius and pocket change. Picture this. It's 1971 in Abilene, Texas. The drag strip at Dyess Air Force Base is packed with the usual suspects: big block Chevelles, Hemi Cudas, Boss Mustangs. These are serious machines with serious money behind them. Then this kid rolls up in a beat-to-hell 1970 Skylark that looks like it barely survived a demolition derby. The paint's faded, the body's crooked, and half the crowd's already laughing. Until he fires it up. That's when everyone stops laughing. The sound that erupted from under that dented hood wasn't the typical Buick wheeze everyone expected. It was thunder. Pure chest-thumping thunder that made the Mopar guys nervous and the Chevy boys confused. What they didn't know was that David Pearson had just solved one of Detroit's best-kept secrets: how to unlock the true potential of Buick's Stage 1 455, an engine so underrated it might as well have been invisible. But here's where it gets interesting. Pearson didn't stumble onto some pristine, numbers-matching Stage 1 at a car show. He found his engine in a totaled 1971 GSX that had been T-boned so hard the frame was bent 30 degrees. The car was headed for the crusher when Pearson spotted it at Coleman's salvage yard outside town. The owner wanted $500 for the whole mess. Most people saw scrap metal. Pearson saw opportunity. To understand why this matters, we need to travel back to 1970, when General Motors was locked in the most intense horsepower war in automotive history. Ford had the Cobra Jet, Chrysler had the Hemi, Chevrolet had the LS6 454, and Buick had accountants. At least that's what everyone thought. While their competitors were throwing cubic inches and marketing dollars at the problem, Buick's engineers were doing something different. They were thinking. The Stage 1 455 wasn't born in some romantic tale of racing heritage. It emerged from a conference room in Flint, Michigan, where a group of engineers led by Clifford Studeker decided they were tired of being the forgotten division. They couldn't match Chevrolet's budget or Chrysler's racing pedigree, so they had to be smarter. The plan was brilliant in its simplicity: build the most torque-focused engine ever stuffed into a production car, but do it so quietly that most people wouldn't even know it existed. The foundation was Buick's already impressive 455 cubic inch big block. But the Stage 1 treatment transformed it into something else entirely. The heads received massive port work, increasing flow by 40% over standard. The camshaft was a hydraulic flat tappet design with 0.490 inches of lift and 280 degrees of duration, aggressive enough to make power, but mild enough to idle smoothly. The Rochester Quadrajet 4-barrel carburetor was specially calibrated to dump fuel like a fire hose when needed, but the real secret was in the bottom end. While everyone else was chasing high RPM horsepower, Buick focused on torque, massive, immediate tire-shredding torque. The Stage 1's 510 pound-feet peaked at just 2,800 RPM. For comparison, the legendary Hemi needed 4,000 RPM to reach its 490 pound-feet peak. The LS6 454 made 500 pound-feet, but not until 3,600 RPM. This wasn't just a number on paper. This was usable, street-dominating power that arrived the instant you touched the throttle. The compression ratio was set at 10.51, high enough to make serious power, but not so high that it required racing fuel. The forged steel crankshaft and connecting rods were overbuilt to handle the massive loads. The pistons were forged aluminum units designed to survive the extreme cylinder pressures. Every component was engineered to work in perfect harmony, creating an engine that made peak torque right where street racers needed it most. So what was actually going wrong with Pearson's salvage yard find? When he pulled the engine from the wreck, Water poured out of the oil pan. The block had cracked when the cooling system ruptured in the crash. The heads were warped. The pistons were seized. The camshaft was bent. Most people would have walked away. Pearson saw it differently. He spent 3 days disassembling the engine on his parents' garage floor, cataloging every part, measuring every surface. The block's crack turned out to be superficial. A skilled welder fixed it for $20. The heads needed milling, but Pearson's uncle ran a machine shop and did the work for free. The pistons were actually fine once he soaked them in penetrating oil for a week. The camshaft was trash, but here's where Pearson got creative. Instead of buying a new Stage 1 cam for $200, he found a standard 455 cam at a swap meet for $15 and had his uncle regrind it to Stage 1 specs for another $10. The valve springs were reusable after testing. The lifters just needed cleaning. The timing chain was stretched but functional. The rod and main bearings showed wear but had life left. Pearson decided to run them. The rebuild process took 6 weeks of evening work. Pearson honed the cylinders by hand using a drill and honing stones borrowed from the local Votex school. He lapped the valves with grinding compound and a suction cup tool. He balanced the rotating assembly using a homemade jig and a gram scale from his high school chemistry class. Every clearance was checked and rechecked with borrowed measuring tools. The total parts bill came to exactly $75, $20 for welding, $10 for cam grinding, $15 for the swap meet, cam, $12 for gaskets, $8 for oil, $10 for assembly lube, and miscellaneous. Supplies. Everything else was either reused, borrowed, or bartered. But the real magic wasn't in what Pearson saved money on. It was in what he understood about the engine that others didn't. While rebuilding, Pearson noticed something interesting. The Stage 1's combustion chambers were smaller than standard 455 heads, but the valves were larger. This created a quench area that promoted mixture motion and resisted detonation. He carefully measured and found he could run 0.035-inch quench clearance, tight enough to create turbulence, but not so tight the pistons would hit. This let him advance the ignition timing beyond factory specs without knocking. He also discovered the Stage 1's ports weren't just big, they were specifically shaped to maintain velocity at low RPM while flowing massive air at high RPM. The short turn radius on the intake ports was particularly impressive, using a ski jump shape that kept the fuel in suspension. Pearson spent hours with a flashlight studying these details, understanding why Buick's engineers made each choice. When it came time to install the engine in his 1970 Skylark, Pearson faced another challenge. The car itself was a disaster. He'd bought it for $300 with a blown 350 small block, a slipping transmission, and rust holes you could put your fist through. But it had one crucial feature, a 12-bolt rear end with 3.42 gears, perfect for the Stage 1's torque curve. The transmission was rebuilt using a shift kit from B&M that cost $30. Pearson modified it himself, drilling the separator plate for quicker shifts and installing stronger springs. The torque converter was a junkyard find from a 1969 Riviera, a 2,200 RPM stall unit that matched the Stage 1's torque peak perfectly. The cooling system used a 4-core radiator from a wrecked Electra. Every modification was calculated to work with the engine's specific characteristics. Now, here's the kicker. When Pearson first fired up the completed engine, it sounded wrong. Not bad wrong, but different wrong. The idle was lumpy, but not rough. The exhaust note was deep, but not loud. It didn't sound like the high-strung screamers everyone was used to. It sounded like controlled violence waiting to happen. The first test drive told the story. From a standing start, the Skylark would literally lift the front tires 6 inches off the ground on street tires. Not drag slicks, not racing rubber, regular street tires. The torque hit so hard and so fast that the car would go sideways if you weren't ready. First gear was essentially useless. Second gear chirped the tires at 40 miles per hour. Third gear would break them loose at 60. This wasn't normal. This was something else entirely. But the real test came at Dyess Air Force Base's 8th Mile drag strip. This wasn't some professional facility. It was literally a taxiway the Air Force let locals use on weekends. The timing system was borrowed from the local sports car club. The ice track prep consisted of whatever rubber previous runs had laid down, perfect for grudge racing, terrible for consistent times, unless you had consistent power. Pearson's first pass was a disaster. He launched too hard, spun through first and second gear, and still ran a 7.8-second 8th mile. The Hemi Cuda in the other lane ran 7.6, but had slicks and a $4,000 engine build. Pearson adjusted his launch technique, feathering the throttle just enough to hook up. Second pass, 7.4 seconds. The crowd started paying attention. By his fifth pass, Pearson had it figured out. Launch at 1,800 RPM, shift at 4,800, let the torque do the work. The result was a 7.1 second pass that converted to an 1150 quarter mile in a 3,000-pound car on street tires with a $75 engine rebuild. The guy with the Hemi Cuda asked to look under the hood, convinced Pearson was hiding nitrous. All he found was a slightly dirty Stage 1 with mismatched valve covers. Word spread quickly through the Texas drag racing scene. The kid with the junkyard Buick was beating cars with 5 times the investment. But Pearson wasn't just winning races, he was changing perceptions. The Stage 1 455 had always been capable of this performance. It just took someone who understood poverty engineering to prove it. The technical reality was that Buick had created something special with the Stage 1, but they'd hidden it too well. Only 100 Stage 1 engines were built across 1970 and 1971. Compare that to over 14,000 LS6 454s or 11,000 street Hemis. Buick produced so few that most people had never even seen one, let alone understood what made them special. The marketing department called it extra performance, which might be the understatement of the century. The Stage 1's design philosophy was fundamentally different from its competitors. The Hemi was an engineering tour de force with hemispherical combustion chambers, dual rocker shafts, and massive ports. Beautiful but complex. The LS6 was Chevrolet, throwing their best technology at the problem: solid lifters, rectangular ports, aluminum intake, sophisticated but temperamental. The Stage 1? It was brutally simple: make everything bigger, stronger, and torquier. No exotic technology, no racing heritage required. Pearson's success exposed something else. The aftermarket had completely ignored Buick performance. While you could buy 3 different brands of headers for a small block Chevy, Stage 1 owners had exactly one choice, and it was terrible. Camshafts? 2 options, both mild. Cylinder heads? Forget it. This forced Pearson and other Buick racers to get creative, modifying parts from other engines or fabricating their own solutions. He started helping other racers optimize their Buicks, sharing the knowledge he'd gained from his rebuild. The quench clearance trick alone was worth half a second in the quarter mile. The ignition timing curve he'd developed added another 0.3, his jetting. Modifications for the Quadrajet solved the bog issue that plagued most Stage 1s. Within 6 months, there were 5 other Stage 1 powered cars running 11s at Dyess, all using Pearson's techniques. The Texas racing scene started calling them the Buick Brigade, a collection of underdogs running GM's forgotten muscle motor. They didn't have sponsorships or matching uniforms. Half their cars looked like they'd been pulled from junkyards, which wasn't far from the truth. But they had something better: engines that made torque like locomotives and drivers who understood how to use it. Think about that for a second. Chrysler spent millions developing the Hemi for NASCAR and drag racing. Chevrolet poured endless resources into the LS6 to maintain their performance image. Ford created entire racing divisions to promote the Cobra Jet. And Buick? Buick quietly built 100 engines that could match or beat all of them, sold them with almost no fanfare, then wondered why nobody bought them. But here's the thing about engineering. Good design doesn't need marketing to be effective. The Stage 1's architecture was so sound that even a damaged example rebuilt with pocket change could dominate at the drag strip. The massive 455 cubic inches provided the foundation. The 10.51 compression delivered efficiency. The huge ports and valves supplied airflow. The massive bore and stroke created leverage. It was physics, pure and simple. Pearson's engine lasted 2 full seasons of brutal drag strip abuse before finally ventilating the block during a money race against a nitrous-fed big block Chevelle. Even then, it didn't go down easy. The engine hydraulicked a cylinder full of coolant, bent a connecting rod 90 degrees, and punched it through the oil pan. Pearson still won the race because the Chevelle scattered its transmission at half-track. The Buick limped across the line, trailing smoke and fluids, but still running on 7 cylinders. The aftermath revealed just how hard Pearson had been pushing that $75 rebuild. The main bearings were down to the copper. The cam lobes were worn nearly round. The valve springs had lost 40 pounds of seat pressure. The ring gaps had opened up enough to stick a dime through. By all rights, the engine should have failed 50 passes earlier, but it didn't, because the Stage 1's fundamental design was that robust. Pearson used his winnings to buy another wrecked GSX, this time with a numbers-matching Stage 1 that needed minimal work. He rebuilt it using everything he'd learned, but with proper parts and machine work. That engine made 535 horsepower on a chassis dyno and pushed his Skylark to 1090s in the quarter mile. Still on street tires, still with a stock appearance, still embarrassing cars with 10 times the investment. The cultural impact went beyond just racing. Pearson's success started a Stage 1 renaissance in Texas. Suddenly, everyone was hunting junkyards for wrecked GSX and Stage 1 Grand Sports. Prices jumped from $500 to $5,000 almost overnight. The few speed shops that carried Buick performance parts couldn't keep them in stock. Buick, which had essentially abandoned performance after 1973, suddenly had dealers asking about Stage 1 parts availability. What made Pearson's story remarkable wasn't just that he beat expensive cars with a cheap engine. It was that he proved knowledge and understanding could overcome money and resources. He didn't have access to flow benches or dynos. He couldn't afford racing fuel or slicks. He didn't have factory support or sponsor backing. All he had was mechanical intuition and the ability to see potential where others saw problems. The Stage 1 4effect5 represented something unique in muscle car history. It wasn't the most powerful engine on paper. The LS6 made more peak horsepower. It wasn't the most exotic. The Hemis had that covered. It wasn't the most popular. The L88 427 had more racing success. But it might have been the most effective street engine ever created, delivering brutal performance with minimal drama. Modern dyno testing has validated what Pearson discovered in 1971. A properly built Stage 1 455 can make over 500 pound-feet of torque at just 2,500 RPM. That's diesel territory. The power curve is so flat you could use it as a reference for construction levels. From 2,000 to 5,000 RPM, the engine never drops below 450 pound-feet. It's not an engine. It's a torque multiplication device that happens to fit in a car. The tragedy is how few people experience this. Buick's marketing department completely failed to communicate what they had. While Dodge was screaming about Hemi power and Chevrolet was plastering LS6 badges on everything, Buick quietly mentioned Stage 1 performance equipment available in tiny print at the bottom of their brochures. They built one of the greatest muscle car engines ever and then forgot to tell anyone. Today, Stage 1 455s are finally getting recognition. Clean examples command 6 figures at auction. The reproduction parts industry has finally caught up, offering everything from aluminum heads to roller camshafts. But the engines that survive are monuments to a different era, when manufacturers could accidentally create masterpieces and teenagers could outsmart million-dollar racing programs with nothing but determination and mechanical sympathy. Pearson went on to become a successful engine builder specializing in Buick performance. He's built Stage 1s for collectors, racers, and enthusiasts worldwide, but he still talks about that first $75 rebuild as his greatest achievement. Not because it was his most powerful engine, but because it taught him that engineering excellence doesn't require unlimited resources. It just requires understanding. The lesson extends beyond just engines. In an era where performance is increasingly defined by computer simulations and million-dollar development programs, Pearson's story reminds us that individual ingenuity still matters, that understanding principles beats memorizing specifications, that sometimes the best solution isn't the most expensive one, it's the smartest one. Consider what Buick achieved with the Stage 1. They took their existing architecture, applied careful engineering, and created something that could compete with purpose-built racing engines. They didn't need dual overhead cams or 4 valves per cylinder or variable valve timing. They just needed displacement, compression, and airflow in the right proportions. It was elegant in its simplicity, devastating in its effectiveness. The Stage 1's influence can still be seen today. Modern turbocharged engines use similar principles: massive torque at low RPM for immediate response, the focus on area under the curve rather than peak numbers, the understanding that street performance is different from racing performance. Buick figured this out in 1970, built it with 1960s technology, and created something that still impresses 50 years later. But the real legacy isn't technical, it's philosophical. The Stage 1 455 proved that there's more than one way to make power. While everyone else was chasing RPM and complexity, Buick chose torque and simplicity. They were right. Pearson proved they were right. And every time someone discovers a forgotten Stage 1 in a barn or junkyard, they prove it again. The story of David Pearson and his $75 Stage 1 isn't just about drag racing or engine building. It's about potential. Every worn-out engine, every forgotten technology, every overlooked design contains possibilities that someone with vision can unlock. Pearson saw potential in a cracked block and warped heads. He turned disaster into domination using nothing but understanding and determination. That's the thing about true engineering excellence. It transcends money, marketing, and even time. The Stage 1 455 was a great engine when it was new, remained great when it was forgotten, and proved its greatness when a teenager from Texas showed the world what it could really do. Not with factory backing or unlimited budgets, but with $75 and the refusal to accept conventional wisdom. In the end, Pearson didn't just outsmart Buick. He revealed what Buick had created but failed to promote. He showed that the Stage 1 455 wasn't just competitive with the legendary Hemi, it was better in the ways that mattered on the street. More torque, more reliability, more accessibility. It just took a kid with no money and nothing to lose to prove it. The next time you hear about some teenager doing impossible things with no resources, remember David Pearson. Remember that $75 engine that terrorized Texas drag strips. Remember that sometimes the best engineering solutions come not from corporate R&D departments, but from garage floors and salvage yards. Remember that knowledge, properly applied, beats money every single time. What's your greatest automotive David versus Goliath story? Drop it in the comments below. If you enjoyed this deep dive into forgotten muscle car history, hit that subscribe button for more stories of engineering excellence hiding in plain sight. Until next time, keep questioning conventional wisdom and remember, the best performance bargain might be sitting in a junkyard right now, waiting for someone with vision to unlock its potential.